Okay, so we have a nice topic here, statistics. We're told a class of 26 students each record a distance in kilometers traveled to school. The distance to the nearest kilometer is recorded below. And so we have 26 records of the distance students travel to school. For instance, one student traveled a distance of 21 kilometers. Another student traveled a distance of 11 kilometers to school. Now, let's look at the table here. We're told to copy and complete it. The first heading, we have distance in kilometers. The next heading, midpoint. In other words, class midpoint. We have the next column, which is frequency. And the next column, we have cumulative frequency. Now let's complete. Let's start with the midpoint, class midpoint. So these are the classes. In the first class, we have the lower limit of 1 and the upper limit of 5. So the first number represents the lower limit and the higher number represents the upper limit. Now to find the midpoint, we basically add the lower and the upper limit and divide by 2. Basically taking the average of both end numbers. 1 plus 5 gives us 6. Divided by 2, that gives us 3. 6 plus 10 divided by 2 is 16 over 2, which gives us 8. 11 plus 15, that's 26. And 26 divided by 2, that gives us 13. If we notice, we need to add 1 to 2. Let me go over that. We need to increase 1 by 2 to get 3. When we add 2 to 6, we get 8. When we add 2 to 11, we get 13. So we can just keep adding 2, and we're going to have 18, 23, 28, 33, and 38. A bit of a faster way. We just basically recognize that the midpoint will be 2 added to each lower limit, or we can say 2 subtracted from each upper limit. But safest way is to add the upper and lower limit and divide by 2. In terms of the frequencies, how many persons travel a distance of 1 kilometer to 5 kilometers? Let's see. This person traveled 3, so that's fall in the class or range of 1 to 5. Let's see, we have another. No, so there's only one person. 6 to 10, we have 1, 2, we have 2 persons. 11 to 15, 1, 2, 3, 4 persons. We have 16 to 20, 1, 2, 3, 4, 5, 6 persons. 21 to 25, we have 1, 2, 3, 4, 5, 6, 7 persons. 26 to 30, 1, 2, 3, we have 3 persons. 31 to 35, 1, 2, we have 2 persons. And then 36 to 40, we have 1 person. Now when we add these up, we should get the total number of persons. Now we are told that there are 26 students. So when we find the sum, the sigma symbol we're going to use for the sum of the frequencies. 1 plus 2 is 3, plus 4 is 7, plus 7 is 14, plus 6 is 20, 23, plus 2, that's 25, plus 1, 26. So that's correct. In terms of cumulative frequency, what we do, we're going to add up each successive frequency. So cumulative means we are accumulating the frequencies. So in the first row, we'll have the same amount. In the second row, we're going to add 1 to the next number, which is 2 here, and we're going to get 3. In the next row, we're going to add the 3 to the 4. That's going to give us 7. Next row, we're going to add 7 to 6. We're going to get 13. 13 plus 7, that's 20. 20 plus 3, that's 23. 23 plus 2, that's 25. And 25 plus 1, that's 26. So the last figure is the same as the total frequency. And what this 3 represents, though, that's so if you understand what cumulative frequency is about. It's saying that since we're in the second row, we're always going to pin this very first lower limit of the first class. And since we're in the second row, we're saying from 1 to 10. How many persons travel the distance of 1 kilometer to 10 kilometers? We add 1 plus 2 and we get the 3. And when we say, okay, for this, what does this 7 here represent? What does that 7 represent? This 7 here is telling us that from 1 kilometer to 15 kilometers, how many persons fall in that range in terms of the distance they traveled to school? Well, it's 1 plus 2 plus 4, and that will give us 7. And so that's the idea. And so let's do one last one so we can understand what's going on. What does 26 represent in the cumulative frequency column? It's telling us a distance of 1 to 40 kilometers. How many persons we have traveled a distance of 1 to 40? That's 26. So that's basically the idea. Okay, now, so what we'll do now, we'll go on since we have completed the table. The next question has been asked is state the modal class. Now the modal class is a class with the most persons, so our highest frequency. So let's look at the highest frequency. The highest frequency here is actually 7. That's the highest frequency. And we go over to see which class has these 7 individuals. And that's the class 21 to 25. So remember we say modal class. So we're looking for the class with the most frequency, or that the class that has the most students. And that's the class 21 to 25. State the upper limit and the lower limit. This one asks for the upper limit, and the upper limit is 35. State the upper limit and lower limit of the class 31 to 35. So the upper limit is 35 and the lower limit is 31. Because they ask about the same class here, so we have to pay attention to that. Now, so the next question asks, what is the mean distance in kilometers traveled by the students to school? For us to get the mean, understand what we're saying here. So let me just do a quick example. Let's say you get $5 on a Monday, $10 on a Tuesday, $20 on Wednesday, and $15 on Thursday. What is the mean of the amount of money you get in the 4 days? This is just talking about the average, the arithmetic mean or average. So what we do, we add up the number of values, 5 plus 10 plus 20 plus 15, and we divide by what? The number of values, which is 4. And the answer to that will be what is known as the mean. Right? The mean average, sometimes referred to as X bar. So to get the mean distance traveled, we're going to do something similar. Okay, so what we're going to do is to examine what we have here. Now, this person traveled a distance of what? Well, since we have 1 to 5, there's no way of knowing exactly what the distance the person traveled unless we go back to the raw data. But ignoring the raw data and looking at just this table, we decide to use the midpoint to represent the distance that this person traveled of 3 kilometers. Similarly, these two persons, rather than going back to the raw data to determine the distance traveled by each person, we use the average, in other words, the midpoint of this class, which is 8 kilometers. So we're saying two persons travel a distance of 8 kilometers. So one person travel distance of 3 kilometers. The other two person travel distance of 8 kilometers. So 8 plus 8. Another person traveled a distance of 13 kilometers. 4 of them. 13 plus 13 plus 13 plus 13. So when we want to find them, I'm going to do the same thing with the rest. So when we're trying to find the mean, we're simply going to add them up. 3 plus 8 plus 8 plus 13. Now instead of saying 13 plus 13 plus 13 plus 13 4 times, we can just simply say 13 times 4. And rather than saying 8 plus 8, we can say what? 8 times 2. And we'll get ours, and we'll continue to add the rest, right? When we get the total, we're going to divide that total by 26, since there are 26 students. And that will give us the mean or average. So it's the same thing as in we would have added up all these 26 data values and divide by 26 to find the mean. But since we're not looking at the raw data, we're looking at the table here, then we'll take the midpoint to represent each of the values of these persons and find the mean. What is the mean distance traveled to school by the students? So we could either use these values or in the table, but it's intended to say using the table, find what is the mean distance or the approximated mean. So what we do, we take the mean to be equal to, and what we're going to do, multiply 1 times 3. So we're saying one person travel distance of 3 kilometers plus the next person, 2 persons travel distance of 8 kilometers. So we're saying 2 times 8 plus, we'll do the same thing with the rest. 4 times 13, 6 times 18, 7 times 23, etc. And we add them up. So we have done that here. As you can look at the last figures, 3 times 28, 2 times 33, and 1 times 38. And we want to divide that by the total number of students. And this will give us, so we multiply out the top and add the values, we'll get 528 divided by 26. Dividing 528 by 26, we'll get 20.307, etc. But let's round this off to the nearest kilometers, and we'll get 20 kilometers. That's our answer in terms of the mean average. Calculate the probability that a student chosen at random from this class recorded the distance traveled to school as 26 kilometers or more. So what is probability? So what we'll do, we'll look at an example. Now probability is really the number of favorable outcomes divided by the total possible outcomes. So before we do question E, let's look at an example. If I should flip a coin, what is the probability that I'll get a heads? Well, what's the total possible outcome? Well, there's a possibility that I could get tails. There's also a possibility I could get heads. So there are 2 possible outcomes. In terms of favorable, what I'm looking for is head, so that's only 1 favorable outcome. And so the probability of getting head is a half. And what we will say, a half is really half of 100%, so that's 50%. So there's a 50% chance of me getting heads. And there's a 50% chance of me not getting heads, which means I'll get tails. So going back to this example, the total possible outcome. So if a student was to be chosen at random, it means that it's a possibility that I could pick any one of the 26 students. Because remember, there are 26 students in this class. So there's a possibility you could pick any one of the 26 students. So the total possible outcome would be 26. But in terms of favorable outcomes, what am I looking for? I'm looking for those students who traveled a distance of 26 kilometers or more. So that will be those students in this class, and this class. Class in terms of the distance traveled. So remember, class is another name for group. So what we know so far is that we have 7 students who traveled 21 to 25 kilometers. 6 students who traveled 16 to 20, etc. But in terms of 26 to 40, or 26 or more, which is really 26 to 40 in this case, 26 or more kilometers, those who traveled, you have 3 students who traveled 26 to 30. So they traveled in the range of 26 or more. These students traveled in the range of 26 or more because they traveled a distance of 31 to 35. This student traveled a distance of 36 to 40. So they traveled, or he or she traveled in the range 26 or more as well. So the total possible outcome is 26, but in terms of favorable outcome, we have 3 plus 2 plus 1. That's 6 students, a possibility of 6 students who actually traveled a distance of 26 or more. So that's a favorable outcome. The 6 students. So any one of these 6 students would have been a favorable outcome. Remember, I'm looking for what? If I choose a student at random, what's the chance of me selecting a student who traveled 26 kilometers or more? Any one of these 6 students would be a favorable outcome because any one of these 6 students would have traveled a distance of 26 kilometers or more. So in terms of the probability of students who traveled 26 kilometers or more, which I'll write like this, probability 26 or more is actually equal to 6 over 26. And so we can actually simplify this by dividing by 2. 3 divided by 2 get 13. So 3 out of 13 is the probability. Simplified, by the way.